Hello and welcome to Best Start Chemistry Tutorials. In today's video, I'll be solving questions on A2 Equilibria. I will specifically be looking at May-June 2019, paper 4.1. Question 1. B. Chloride ions can be identified using aqueous silver nitrate, AgNO3 aqueous. The ionic equation for this reaction is given as Ag plus aqueous plus Cl minus aqueous, giving you AgCl solid. 0.303 grams of a chloride of sulfur is completely hydrolyzed with water. All the chlorine atoms present in the chloride of sulfur are converted into chloride ions. The solution is diluted to 100.0 centimeter cube. A 25.00 centimeter cube sample of this solution is titrated with 0.0500 mole decimeter cube silver nitrate aqueous. The titration requires 22.40 centimeter cube of 0.0500 mole decimeter cube AgNO3 aqueous. Calculate the empirical formula of the chloride of sulfur. Show all your working. In this question, the total mass of the chloride of sulfur has been given as 0.303 grams. But an information has also been given that will help us calculate the mass of the chloride in the chloride of sulfur. And once we know the mass of the chloride, then we can subtract from the total mass, which is 0.30 grams, to also find the mass of sulfur. And once we know the mass of the chloride and know the mass of the sulfur, we can easily determine the empirical formula. Now, to find the mass of the chloride, we can see that the chloride has been titrated with silver nitrate solution. And to do this, we have to first of all calculate the amount of the silver nitrate solution. And amount is equal to concentration times volume. And so this is equal to, the concentration is 0.05 mole per decimeter cube times the volume, which is 22.4 centimeter cube. So we convert this to decimeter cube by dividing by 1000, or simply by multiplying with times 10 power minus 3. When you do this, you get 1.12 times 10 power minus 3 mole. Now we want to find the amount of the chloride ions in the 25 centimeter cube of solution that reacted with the silver nitrate. To do that, we use mole ratio. So the mole ratio between the silver nitrates, in this case the silver ion, and then the chloride ion is 1:1, as given by this equation. And so it means that in the 25 centimeter cube solution, the amount of chloride ions is also the same as 1.12 times 10 power minus 3 mole. However, the total volume of solution in which the chloride ion was found is 100.0 centimeter cube. But we took only 25 centimeter cube out of that and titrated with the silver nitrate. So it means that to find the total amount of chloride ions in solution, we have to multiply this amount by 4 to know the total amount in the 100 ml of solution. And this gives us 4.48 times 10 power minus 3 mole. Now we want to find the total mass of chloride in solution. And so mass of chloride is equal to amount times the molar mass. And that is equal to the 4.48 times 10 power minus 3 mole times the atomic mass, or the molar mass of chloride in this case is 35.5 grams per mole. And that gives us 0.159 grams. Now, to find the mass of sulfur in the chloride of sulfur, we have to subtract the mass of chloride from the total mass of the chloride of sulfur, which is 0.303 grams. So the mass of sulfur is equal to 0.303 grams minus 0.159 grams. And that gives us 0.144 grams. Now, for empirical formula, we write sulfur here, we write chlorine here. The mass of sulfur is 0.144, whilst the mass of chloride or chlorine is 0.159. And we divide this by the atomic mass of sulfur, divide this by the atomic mass of chlorine, which is 35.5. And so for sulfur, that will give us 4.499 times 10 power minus 3. And that of chlorine gives us 4.479 times 10 power minus 3. So you divide with the least amount, which is 4.479 times 10 power minus 3. And this one too by 4.479 times 10 power minus 3. And this gives us 1. This also gives us approximately 1. So it means the empirical formula will be SCl. Question 7. D. When concentrated sulfuric acid is added to water, dissociation takes place in 2 stages. Stage 1. H2SO4 dissociates to give H plus HSO4 minus ion. This HSO4 minus undergoes second dissociation in stage 2 to give H plus SO4 2 minus with the Ka2 expression with the Ka2 value as 1.0 times 10 power minus 2 mole per decimeter cube. Ka2 is the acid dissociation constant for stage 2. Write the expression for the acid dissociation constants Ka2. So for this one, we are going to use the second stage, and the acid dissociation constant is equal to the product of the concentration of H plus and concentration of the SO4 2 minus divided by the concentration of HSO4 minus. H2SO4 is considered a strong acid, whereas HSO4 minus is considered a weak acid. Suggest how the magnitude of the acid dissociation constant for stage 1 compares to Ka2. So that is for stage 2. Now, H2SO4 is a strong acid and is the one undergoing the dissociation in stage 1. And HSO4 minus is a weak acid, is the one undergoing dissociation in stage 2. The Ka value for a strong acid is always greater than the Ka value of a weak acid. So Ka1 is expected to be far greater than Ka2. E. Benzoic acid C6H5CO2H is a weak acid. A solution of 0.0250 mole per decimeter cube benzoic acid has a pH of 2.90. Calculate the Ka of benzoic acid. Now, when you have a question like this, the first thing to do is to write the dissociation equation of the benzoic acid. So you have COOH aqueous, and this will dissociate to give us C6H5COO minus aqueous plus H plus aqueous. Now, for the initial concentrations, that of benzoic acid has been given as 0.0250 mole per decimeter cube. But at the start of the reaction, the benzoic acid has not dissociated yet, so this will be 0 and 0. But at equilibrium, The concentration of benzoic acid will still be 0.0250 mole per decimeter cube, since whatever is ionizing to give the ions is very insignificant. And so because of that, we just assume that almost nothing has really gone out of this. In the question, the pH has also been given as 2.90, and this pH can help us calculate the concentration of H plus. And we know that pH is equal to negative log concentration of H plus of H plus. So 2.90 is equal to negative log H plus ion concentration. And so if you divide through with negative 1, it means this will be negative 2.90, which is equal to log H plus ion concentration. And so if you find the anti-log of this, it means that the H plus ion concentration is equal to 10 exponent negative 2.90, which is equal to 1.26 times 10 power negative 3 mole per decimeter cube. So back to this, the concentration of H plus at equilibrium is 1.26 times 10 power minus 3. And since the mole ratio between the benzoate ion and the H plus is 1:1, and then their concentrations are also the same, so at equilibrium, it means that this will also be 1.26 times 10 power minus 3. Now, the Ka expression for this is equal to concentration of the benzoate ion times the concentration of the H plus divided by the concentration of the benzoic acid. And so since we know their concentrations, we just do the substitution, and this will be 1.26 times 10 power minus 3. This is also 1.26 times 10 power minus 3. So I can do exponent 2, and this is 0.0250, and the K value is 6.34 times 10 power minus 5 mole per decimeter cube. Thanks for watching, and see you in my next tutorial.